Hello friends. So this is the tension problem. So here I have a mass and the mass of this block is given, and let's say m is equals to 60 kg, and this block is connected through two ropes. So one rope is here and another rope is here, and these two ropes make some angle with the horizontal. So this is the horizontal line, if you see, or I can make black. So this is the horizontal line. So this angle is given. This angle is 60 degree and this angle is 30 degree. So these two angles are given in this case, and we have to find tension in each rope. So there are two ropes. Now this block will try to apply a force in the downward direction. So basically there will be a force and this will be in the downward direction, and this force is mg. And due to this force, these two ropes will be stressed, as I said earlier also. So you consider rope as a spring. Imagine, mentally you imagine this is a spring and this is also a spring. So what will happen? These two springs are stretched. So due to this weight mg, these two strings or these two springs, which is imaginary springs, is stretched. This means in this rope there will be a force in this direction, and in this rope there will be a force in this direction. Because if a spring is stretched, then what will try to do? It will try to push this block this side. So now I know the direction of tension. So basically once you imagine rope as a spring, then you can directly find the direction of tension. So on this block the direction of tension will be this side, on this block direction of tension will be this side. So what are the forces that is acting on this block? So one force is mg, and let us call this tension as T1 and this tension as T2. These two tension will not be same because these ropes are not identical. They have different kinds of rope. They have different environment. One is at inclined at 30 degree, another is at 60 degree. So this tension will not be same. Now component of this tension T1 in this direction we will have, and this is T1 cos theta, and theta in this case is 60 degree, and in the vertical direction this component will be T1 sin 60 degree. Similarly T2 will have a component, this direction you will have T1 sin 30 degree, and in the vertical direction this is T2, you will have this is cos 30, and in the vertical direction you will have T2 sin 30 degree. So this is the component of forces. You can consider this is x-axis and this is my y-axis. Now block is in equilibrium, block is in the rest, so there is no forces acting, there is no unbalanced forces are acting basically. So there is no acceleration, so we can say force is equals to mass into acceleration. Acceleration is 0, so force is equals to 0. So we will say forces in x direction is equals to 0 and forces in y direction is equals to 0. So let us apply this. So if I consider sum of the forces in the x direction is equals to 0, this means what we will say, one force that is T2 cos 30, and this is opposite direction, minus T1 cos 60 is equals to 0. So from here I can say T2 and cos 60 is nothing but root 3 by 2, and T1 cos 60 is 1 by 2 is equals to 0. So we can say T1 is equals to root 3 T2. So we will have this one expression. So there are two unknowns T1 and T2. we need to have two equations. Second equation will come from equilibrium in the y direction. So sum of the forces in the y direction is equals to 0. So what are the forces that is acting in the y direction? T1 sin 60, T2 sin 30 and minus mg. So sum of all these forces is equals to 0. So we can say T1 sin 60 plus, this is in degree, T2 sin 30 degree minus mg is equals to 0. So now you can solve for T1 and T2. So T1 sin 60 is root 3 by 2 plus T2 sin 30 is 1 by 2 is equals to mg. So from here I can say T1 root 3 T1 plus T2 is equals to 2 mg. So now I have two equations and two unknowns. What are the unknowns? T1 and T2 are unknowns. So we can solve for these two unknowns. So from equation 1 I can say, so from 1, T1 is nothing but root 3 T2. So root 3 multiplied by T1 is nothing but root 3 T2 plus T2 is equals to 2 mg. So from here I can say this is 4 T2 is equals to 2 mg. This means T2 is equals to mg by 2. And mass of this block is given, which is 60 kg. So if you remember, mass of this block is given, that is 60 kg. So if you plug this value, T2 is equals to 60, and let us assume G is 10 meter per second square. So 60 into 10 divided by 2, so this is 300 Newton. Similarly, T1 will be, what will be T1? T1 is what? So T1 you have, so relationship T1 is equals to root 3 times T2. So root 3 times T2, this means 300 root 3 Newton will be the force in the second row. So you have seen how we can solve this for tension. Now a question for you. What will happen? Let's say I have a third rope. So this problem has a third rope also. Angles and everything are given. So if I have a third rope somewhere here, let's say the third rope is somewhere here. So this is the third rope that basically passes through this point as a vertical. So this third rope, now you will have three tensions. So T1, T2, T3. Now the question is, will you be able to solve this problem? You will have T1, T2, T3. So will you be able to solve this problem or not? So let us discuss in the comment box, and what other condition will be required to solve such kind of problem. So I will see you in the next video. I hope you enjoyed the video. If you enjoy, please share with your friends. And this problem is regarding tension in the rope. I will discuss more problems related to tension in the rope. Thank you.